In this video, we will be talking about the derivative of the natural log function. Recall, the natural log function is simply what we call ln of x. It is basically log of base e of x. Instead of writing log base e, we simply use the notation ln of x. So I'll give you the theorem for this. It's pretty straightforward. So the derivative of the, I'll just simply say ln of x. We have a couple cases. So first, let u be a differential function of x. That just means that we could take the derivative. The derivative exists. Then the following two things are true. The derivative with respect to x of ln of x is equal to 1 over x whenever x is bigger than 0, strictly bigger than 0, that is. Because remember, we cannot have negative or 0 in logs. We have a, let me just remind you, the graph of log looks like this, and it has a vertical asymptote at 0. And 2, the derivative with respect to x of ln of u, where u is a function, is equal to 1 over u times the derivative of u with respect to x, which is basically simplifies to u prime over u, the derivative of u divided by u. In this first case, x is a number. So we're saying ln of x is like saying ln of 3. That's a number. The second case is when we have ln of an actual function. I'm not actually going to give you the proof of this, but you could find it online. Let's do a couple of examples of how we do this type of problems. Let's say somebody told you to find the derivative with respect to x of ln of 2x. Well, by our rule, that derivative should be u prime over u. Well, what is u? U is this inner function to x, which means that the derivative of u prime, is the derivative of 2x, which is simply 2. And if we put this together, we have u prime divided by u. Well, u prime, we just calculated that to be 2. And then u, we calculated, well, u is still u, so u is just 2x. U hasn't changed. So this is simply 2 over 2x, and because 2 divided by 2 is 1, we can actually cancel, and we have just simply 1 over x. This is a pretty straightforward problem. Let's do another one. Let's say somebody asks you to find the derivative of ln of x squared plus 1. Well, once again, this is the same thing as having u prime over u. I typically don't think about this when I do the problems as u prime over u. I actually think about it as, this is an aside, the way that I think about an ln problem like this one, like ln of x squared plus 1, yeah, plus 1. I do 1 over u, and then I just multiply by u prime. I like to have them separate, and then I combine them. It just helps me keep the work separate. So, in any case, when you begin to get good at this, you'll see what I mean by that when you begin doing it in your head. Let's see what u is. U is the inner function, which is x squared plus 1. That's supposed to be a 1. And that means that u prime, the derivative of u, is equal to 2x plus 0, because the derivative of 1 is 0. Which in turn means that the derivative of ln of x squared plus 1, so d dx, derivative with respect to x, of ln of x squared plus 1, is actually equal to 1 over u times u prime, well, that's the same thing as 1 over x squared plus 1 times 2x, which is equal to, let me do it on this side, which is equal to 2x over x squared plus 1. So we have that d dx of ln of x squared plus 1 is equal to 2x over x squared plus 1. So one more. We kind of getting the hang of this, right? So d dx, somebody comes up to you and tells you find the derivative of x times ln of x. Here we have a trickier situation. Here we have one function multiplied by another one. Again, we have one function multiplied by another one. We have a product, so we have to use the product rule. Here we have d dx of f times g, which, if you recall, this is g times f prime plus f times g prime. So let's get our f's and g's. So let me say f of x is equal to x. Let's say g of x is equal to ln of x, because I have to use the product rule. Well, what is the derivative of f? Simply 1, because the derivative of x is 1. And what is the derivative of g? Well, this is from the definition, way up here. The derivative of ln of x is just 1 over x, so long as x is positive. Well, here I have the derivative of ln of x is just 1 over x, by definition. Now I can actually solve this. So this derivative of here, I'm just going to rewrite it down here. So d dx, the derivative with respect to x of x times ln of x is simply equal to g times f prime. So that's ln of x times 1 plus f of x, which is x, times 1 over x, which is g prime of x. I'm basically doing the product rule here. Well, ln of x times 1 is simply ln of x. And x times 1 over x is the same thing as x divided by x, which is just 1. So, plus 1. So we have that the derivative of x times ln of x is simply ln of x plus 1. Okay? So that's the solution to this problem. You have to be able to identify whenever you have a product. So let me just give you a caution. You must remember to look out for products and quotients when taking derivatives. Okay? You must always remember that. You should always look out for them. For example, if somebody gives you y equals 2x times cosine of x squared plus 1, here you have a chain rule, we have a product rule happening all at the same time. Okay, so you gotta be very careful. And you could even throw in a quotient rule if I were to divide by, let's say, tangent of x. So this will get very complicated very quickly. So always be on the lookout for that. Let's do 1/4 example, and then I'll move into a general example, and then that will be it for this section on ln of x. So let's say somebody tells you on the bus, somebody comes up to you and gives you ln of x cubed, and they told you to find the derivative of that. This is an example that involves the power rule, the general power rule, because we have u to a power n. That's what we're dealing with here. Well, u here is simply ln of x. And f of u is equal to u cubed, because we're raising it to a cube power. The derivative of u, the derivative of ln of x, by definition up there that I gave earlier, is 1 over x. And the derivative of u, of f of u, is equal to, again by the power rule, 3u squared. So if you put this together, we have 3u squared times u prime, because of the chain rule. Remember the general power rule, we have to multiply by the derivative. But u is simply ln of x. This is 3 times the ln of x squared times u prime, which is simply 1 over x. And I will leave it like that. That's an acceptable answer. So here you have to be a little bit careful. Here you have to remember we're using the general power rule. Here we're using the fact that the derivative of ln of x is 1 over x. And here we're using the power rule, the basic power rule from 2 lectures ago. Now, the properties of logs, which hopefully you remember from pre-calculus, are still very useful here. So if you remember from pre-calculus, if you have log of a times b, that's the same thing as log of a plus log of b. If you had log of a over b, that was the same thing as log of a minus log of b, and ideally also ln. If you had log, let's say, of a to the power x, that's the same thing as x times log of a. So all these rules will be very useful. Remember the one-to-one property. If you have, let's say, log, and let's say it's mostly going to be useful for ln, so let me just write it with ln. If you have ln of e to the x, then that's just x. The ln and e cancel out. That's the one-to-one property. Similarly, I'll just write it on this way. If you have e raised to the ln of x, that's also x. The e and the ln cancel out. And for logs is if you have log base a of a, let's say to the b, then you just get b. Or if there was no exponent, then you just get 1. Okay, so I'm mentioning that because it's going to be useful for us. So let's say somebody comes up to you in the train and tells you, hey, differentiate the following. Differentiate f of x equals ln of the square root of x plus 1. Okay, if somebody comes up to you and asks you to do this, then it's important to know all of these rules of logarithmic functions, of the logarithmic function. So the first thing I will do is try to rewrite it. So f of x equal to ln or square root of x plus 1 is the same thing as ln of x plus 1 to the power 1/2. That's number 1. Which in turn, by this rule right here, I could bring that 1/2 to the outside. So I could bring this 1/2 to the outside, so that means that f of x is actually equal to 1/2 times ln of x plus 1. So I'm allowed to do this. And now we can actually take the derivative. So let's take the derivative of this. Here, what I have here for my u is x plus 1, and f of u is simply 1/2 ln of x, or ln of u, in this case. U prime, the derivative of this is just 1, and f prime of u, the derivative of f, is simply 1/2, and remember, ln of u, the derivative is simply 1 over u times u prime, so times 1 over u times u prime. So we're ready to put this together. So the derivative of f of x is equal to 1/2 times 1 over u times u prime. And I know what u prime is and I know what u is because I calculated them here. Well, that means that f prime of x is equal to 1 over 2 times 1 over x plus 1 times u prime, which is 1. Remember, when we have fractions, when we're multiplying fractions, we multiply across. So 1 times 1 times 1 is 1. And then 2 times x plus 1 is simply 2 times x plus 1. And, you know, you could FOIL that out, so that's 2x plus 2, if you want to FOIL that out in the denominator. And that will be the solution for this problem. So like I mentioned, being able to actually remember these rules from up here can be very useful when dealing with problems involving the logarithmic function. I'm going to leave a problem as an exercise for you to try. It's definitely more of a challenge problem, but if you could do it, then you're in good hands. So find f prime of x for f of x equals ln of x times x squared plus 1 squared divided by the square root of 2x cubed minus 1. This looks much more difficult than it is. If you apply the rules that are up here, you'll be in good hands. The hint that I will give you is to use the rules of addition, meaning of multiplication and division, first before you try to get this exponent to the outside. Okay? That's the biggest hint that I could give you. Thank you for your attention in this video.